Good day everyone, and welcome back to my channel where we make mathematics easy for everyone. For today we'll be looking at inverse functions, that is grade 12 functions. How to sketch the graphs of inverse function graphs, and how to also rewrite the equations of inverse functions. Now we have question 1 asking us to sketch the graph of g of x equals to 2x plus 4 and f of x equals to x squared. What do? Let's first of all complete our platform where we're going to sketch. We have -2, -4, I have 2 negative and -4, 2 and 4. If we need more space, we are going to create more extend the lines. Now the graph of f of x squared is an interesting one because we know that the turning point is also equivalent to the y-intercept in this case, and both of them are at 0. And because it's a positive graph, I can take it up and I can take it up. And this is a graph of f. Done. Nothing else. And then for g of x, it's a linear function. We know it is of the format mx plus c, where c represents our y-intercept. Our y-intercept in this case is 4. Now, what do we need more? We make y 0 to get our x-intercept. So if we solve this, we have -4 equals to 2x. X will be equals to -2. So our x-intercept is at -2 and 0. So we can join this. It creates our linear graph. So this will be our linear graph. So in this case, we have our f and we have our g. So we have the two functions. Let's go to the second question. They are asking us to write out the equations of the inverses of this, and also sketch the graphs of all the same set of axes. Now let's start with g of x is written as 2x plus 4. The inverse, the notation is this inverse function of x. Please note the difference between this. It's not a reciprocal. Reciprocal of 1 over x is x over 1, but this is not a reciprocal, but it is inverse. Also note the difference between this and this. If you have an apostrophe in front, it means the first derivative. So we don't mix them up. It's not an inverse, just like we have the exponent of -1 of any value is an inverse. So this is not exponent, it's function, so it's talking about the inverse, and it's not talking about derivative. What are the rules? The first thing is swap x and y, their position. So here x becomes y and y becomes x. And then still make y the subject formula, because any function must be y with relationship with x. So if we keep y here, this becomes x, we swap x and y, we have this becomes x minus 4 equals to 2y. So the equation of y will be x over 2 minus 2. This is the equation of the inverse. So we can rewrite this as the inverse equation of g. The inverse equation of g in this case will be this. If we check properly, we'll see that this also generated a linear function. So the inverse of a linear function gives you a linear function. What do we do next? Let's sketch the graph of the inverse on the same set of axes. -2 is our c, so that serves as our y-intercept. Our x-intercept make x 0, make y 0, So we have 0 plus 2 equals to x over 2. So x equals to 4. Our y-intercept will be at x. X-intercept will be at x equals to 4. So if we sketch this graph, we'll see that we have, this is a different color, we will have this graph, we will have this linear graph. Which if we extend this, then we'll have a line of symmetry in between them. So, what do we observe here? Look at another way of doing this faster. Our y-intercept here is 4 and 0. Our x-intercept is 4 and 0. Our y-intercept is 0 and 4. Did you see the change? 0 and 4, 4 and 0. Swap x and y in every coordinate. Look at this. Negative 2 and 0 from the original. From this one, it becomes 0 and negative 2. So you can just take every coordinate on the graph, swap x and y, and it gives you the actual value that you want to sketch the inverse function. So this is the inverse of g, whereas this is our g. Now let's look at sketching our f, the inverse of f. Let's look at sketching the inverse of f. What do we do? Y equals to x squared, that is the 7. If you check here, the inverse of g is also a one-to-one relationship, which is also a function, so we have no problem with that. Now let's go to this same approach, swap x and y. We have y squared is equals to x. Remember that when we have many y values to one x value, it's not classified as a function, but a relationship. But we want to obtain a function on our sketch. We'll see how we go about that. So the next thing is make y the surrogate formula. So y is plus or minus root of x. Now, they say restrict the domain. How do we make it a function? Because if we sketch this graph, we will have something like this, which will not pass the vertical line test and it will not be classified as a function. So what do? We restrict the domain of f in a way that it gives us a function. How do we restrict? We look at our turning point. From our turning point, that is where we have the symmetry. We can divide the graph into two equal parts. So we have two parts that will still generate inverses that are functions. So our symmetry is at x is equals to 0. So we can say x is greater than or equals to 0 will be one part, and x is less than or equals to 0 will be one part. Let's look at this. Suppose that we sketched this graph and we got this point at 2 and 2. Let's do something else. Yeah, 2 and 2. Let's be more practical. If I get 3 and 3, 2 and 2, yes. Sorry, I want to adjust this because 2 and 2 will not give me exactly what I want. Let's do something else. Let's say I get 3 as a coordinate here, and I get something like 2.5 here. For inverse functions, what do I do? Swap around x and y. Swap around x and y. So what does it mean? X will now become 2.5. And y will become 3. So I can have this point here. So my inverse function graph will give me this. That is the first arm. Only when x is negative. Instead of having this that will not pass the vertical line test, I will have one part. And this part only works with the positive arm as we presented in our restrictions. Now, for the negative arm, let's also get another point here. Let's say we also have the same thing. Let's say we have negative 2 and 2.5 on this graph. So what do? We also take the inverse by swapping the x and y value. X value here is negative 2, y value is 2.5. So we can also change this to become 2.5 and negative 2. So we can have 2.5 for x and negative 2 for y. So we'll have our graph here. So this will be the inverse of this, and this will be the inverse of f. So for them to generate a function, the positive arm must work with this on the positive arm. The negative arm, then this whole length becomes a graph for the negative arm. So we can't take both of them. We have to take this or this for us to have a proper inverse function. In the next video, we'll go through exponential graphs and logarithmic graphs and see how they also work. But for now, keep on sharing. I'll see you in the next video. Enjoy the rest of your day.